fighter planes designed to operate at sea. A colossus of the air, equipped with torpedoes. Jets equally at home at altitude or just low above the waves. The French Navy isn't only about ships and submarines. In its arsenal, there are some exceptional aircraft too, piloted by sailors.
I think we're all sailors before we're pilots. In fact, we're called flying seamen.
And one of their most potent weapons is the specially configured Rafale, the only aircraft in the world with delta wings that can land on a carrier deck. To hit enemy ships, its weapons can be fired with impressive accuracy. The Atlantique II, with its airliner dimensions, also boasts exceptional armaments. It carries torpedoes in its belly, ready to be released into the sea to incapacitate hostile submarines. The ATL-2, of which 28 have been built, can prowl over the sea for more than 10 hours. A veritable bird of prey that's on a par with another of the Navy's gems, the Falcon 50. A trijet specialized in maritime surveillance. Its forte, being able to fly very high to go very fast. And to descend very low to check on any suspicious boat or ship.
At 100 feet above sea level, that's 30 meters, well, there's not much room for mistakes.
The Rafale Marine version, the new ATL-2 submarine hunter, the ultra-fast Falcon 50. 3 technological gems that are the pride of the French Navy. After the United States, France's territorial waters are the second largest on the planet. Nearly 11 million square kilometers. Off the coasts of the mainland, but also in distant regions like Polynesia or the Indian Ocean. An area that large requires the French Navy to be on constant alert. It's a job of awesome dimensions, and the options for action are up to the task. There are nuclear attack submarines, technological gems, the latest of which, the Suffren, has just left the French shipyards. There are also multi-role frigates. And there's the Colossus, the aircraft carrier Charles de Gaulle. It's a strategic asset of the highest order. Since, in order to monitor the oceans and to react in a crisis, the fastest and most effective means are planes. In this case, they're navalized aircraft, because flying at sea is very different from flying over land. And to comply with that, France has the ultimate fighter, the Rafale. In an exclusive configuration, the naval version of the best fighter jet ever. The Rafale represents state-of-the-art technology. Designed by the Dassault Aviation Company, it has proved an immensely versatile combat plane. Able to fly at Mach 1.8 or 1,912 kilometers per hour.
Acceleration is enormous.
The Rafale can fly at 50,000 feet. In other words, more than 15 kilometers above sea level, way above airliners. It can deploy across France, from Lille to Marseille, in 28 minutes. It's equipped with the latest weaponry, be it missiles, bombs, or cannon. And its naval version carries yet another special weapon: air-to-sea missiles.
We operate in an air-sea environment, so we also train for missions against ships.
A shipping strike is very different from a ground attack. That's what the AM-39 was designed for.
To neutralize a ship, you have to damage a comparatively large area as opposed to when attacking a tank, which is a rather small target. So you don't need the same ammunition to deal with it.
The naval Rafale represents the culmination of French aircraft engineering. To allow it to evolve in a maritime environment, it required a specific design, a prerequisite taken into account from the very genesis of the program. Since on the Charles de Gaulle, its launch base, the Rafale does not take off, it's catapulted. As the 80-meter runway is too short, it is the ship itself that sends the plane into the air.
Below the deck of the carrier is the catapult system. On the Charles de Gaulle, it's driven by steam.
Launching the aircraft in less than 2 seconds requires enormous pull. Yet the carrier is provided with the ultimate energy source: nuclear power. 2 unique power plants at the heart of the ship produce extreme heat.
We accumulate steam and release it suddenly in a piston, and that pulls the plane right to the end of the deck.
The landing gear is attached to a sort of shoe, which is itself connected to the piston. The link between the landing gear and the catapult consists of a single piece.
It's a small bar on the plane's nose gear.
It's about this size. It's made of titanium, as it has to tow the whole weight of the plane.
The naval Rafale is also equipped with an integrated ladder not found on the classic version. For safety reasons, a minimum of parts is needed on the deck of a carrier. Once the pilot is in the cockpit, the landing gear is attached to the catapult shoe. The turbine is now running. It's not yet moving the plane, but just sucking in air through its intakes. No one must be in front of the plane during this sequence. However, there's also danger at the rear of the aircraft. The turbine's exhaust reaches several hundred degrees Celsius. Hence, the deflector behind the catapult. The large plate is more sophisticated than it appears. When up, it's subjected to intense flows of hot air. When back in a horizontal position, people can be burned by stepping on it, just as the deflector can seriously damage aircraft tires.
To prevent the deflector from melting, we have to cool it down. We use, quite simply, seawater, which passes through a system of coils inside the deflector to keep it at a moderate temperature, allowing us to use it for the next launch.
The use of deflectors is a special feature of the plane's naval version. Just like the aircraft's silhouette, it's different from the classic Rafale. For example, the nose is raised to allow for more lift during catapulting. When all lights are green, the Rafale can be set in motion.
We go from 0 to about 250 kilometers per hour in 75 meters, just over 2 seconds.
The acceleration is phenomenal.
It's 5G for the pilot, so it's really violent.
5G is 5 times the body weight felt by the pilot. A man weighing 80 kilograms will feel like he weighs 400.
It's linear, but since it's in a short space of time, it is indeed brutal.
When catapulted, the Rafale weighs 20 tons. To reach an acceleration of 5G, the catapult has to provide 100 tons of pull. Each time, the 1,600 crew members feel a sort of muffled explosion. The ultra-strong alloy of the nose gear is specially designed to withstand the sudden shock delivered by the steam catapult. The ingenious gear also allows the wheels to rotate 360 degrees. Given the limited space on a carrier deck, it's a major advantage when maneuvering the plane.
The navalization of a combat aircraft has to be taken into account in the initial specifications of its design. It's not something you can adapt later.
On the deck of the Charles de Gaulle, you can see an impressive, carefully rehearsed aircraft ballet.
We're aiming to launch a plane every minute per catapult, so with 2 catapults, it's 1 plane every 30 seconds. Thus, the planes must be as close by as possible to ensure an unbroken sequence.
On the deck, steam is an indication of hidden machinery in action.
It's just water vapor coming out of the catapult rail.
In a few years, the distinctive steam will be a sight of the past. There are other, less traumatic techniques for getting a plane off the ground from runways just 80 meters long.
Every catapult launch puts immense stress on the plane's landing gear.
On the successor to the Charles de Gaulle, there'll be electromagnetic catapults, similar to those in use on American carriers today.
There are many missions for a naval Rafale, yet its weapons make it particularly effective in all sorts of conflicts. The AM-39 is one of them, an air-to-sea missile. 4.7 meters long and weighing 165 kilograms, the missile approaches the speed of sound as it heads straight for its target. It skims the sea, barely above the waves, at a height of 2 meters. Yet, the naval Rafale also has bombs. They're intended for missions over land, if the Rafale is sent to support ground operations. And they, too, are of phenomenal precision.
We've guidance systems that are so precise that a bomb weighing 250 or 500 kilograms, or even a ton, can be directed into a window measuring 1 square meter.
A powerful armament for attack. Yet the plane also has a defense system among the best in the world. It's designed by Thales, a French company and a world leader in the field. Its engineers have developed the Spectra. Its sensors provide aircraft identification, target localization, jamming, and decoys against attacks in flight. It's a highly complex data fusion system.
The Spectra is at the front and at the rear on the wingtips, so we have the largest possible zone of defense around the aircraft.
Installed all over the aircraft, Spectra provides a 360-degree analysis of the Rafale's environment. The exact range of its performance is confidential. It's estimated at several dozen kilometers. The system identifies the threat and releases an appropriate decoy. If the hostile missile's radar works on infrared, it targets the aircraft's turbine. Its priority is to head for the highest amount of heat. Spectra then emits a row of small, incandescent cartridges. They provide a huge source of heat, far more than the plane's engine. The missile turns in the direction of the decoys, while the plane can escape. Yet, there are other types of missile guidance. They focus on the plane's mass of metal. As infrared decoys are ineffective against this particular threat, another system comes into play. Metallized flakes, ejected from the aircraft in large quantities.
The missile is looking for the magnetic source, i.e. the metal, and will think, instead of going for the small area, which may just be a piece of debris, I'm going for the larger target, which must be the plane.
Differentiation between electromagnetic and infrared-guided missiles is vital. The Spectra system is one of the Rafale's key assets. Combined with missiles and bombs, the aircraft is used in a wide range of missions. Operations that can last 5, 6, 8 hours, and sometimes even longer. The Rafale never sets off on a mission very far from a tanker plane. The fighter might have to refuel 4 or 5 times before and after combat, a delicate operation. Since the pole used to collect the kerosene has to connect with a basket barely 50 centimeters wide at 600 kilometers per hour. The pilot can thus recover up to 10 tons of kerosene at each refueling. A complex exercise, but not as perilous as the final stage of a flight. Unlike the Rafales of the French Air Force, after a mission, the Navy's aircraft must accomplish one last feat. And it's not the easiest, getting down onto the carrier deck. Landing on the Charles de Gaulle after a 7 or 8 hour mission requires exceptional concentration. One wrong move, and the plane may crash. In the best case scenario, it will go straight down the deck and plunge into the sea. In the worst case, it will slam into the island, the bridge on the right of the carrier. With missiles, bombs, 2 nuclear power plants, and a crew of 1,600 below deck, this scenario could spell disaster. That's why the pilots are constantly practicing their landing maneuvers, either in a simulator or on land, at the Land Division base in Brittany. On the runway, there's the same device as on an aircraft carrier, the arresting wire, a steel cable made up of twisted strands. The plane must catch it to cut its run on the deck. To bring the aircraft to a stop after just a few meters, the cable is held in place by hydraulic presses.
They'll capture the plane's deceleration energy.
A principle as simple as it is effective. Yet at sea, it amounts to acrobatics. After all, the plane is descending at around 250 kilometers per hour, and the deck is not stable.
That's why we're sailors. You need to know the sea, its state, in other words, the environment of the carrier, to be able to land safely.
To achieve this, the naval Rafale is fitted with a crossbar at the rear of the fuselage. It will grip the wire. However, before reaching this stage, the pilot must perform several other tasks. And the first is to find the Charles de Gaulle. The aircraft carrier can sail 1,000 kilometers in 24 hours. So enough kerosene is needed to make it back and for an approach from in front of the Charles de Gaulle, which will be steaming into the wind. The first step is to lower the grip. In the cockpit, a clearly visible yellow and black hook triggers a hydraulic mechanism.
The pilot pulls the lever, but he can't be sure that the grip is actually down.
So you have to trust the light on the dashboard. It indicates that the hook is extended. If it isn't, the pilot has no way of stopping. For this sequence, the people on the bridge are indispensable. As the pilot approaches, they check whether the hook, the landing gear, and the canards, the small additional wings below the cockpit, are in the right position. They then inform the DLO, the deck landing officer. Without their go, the aircraft must not attempt a landing. All DLOs are experienced pilots.
At some point in their career, they choose to qualify as deck landing officers, parallel to being Rafale pilots. They're at the back of the carrier, as you'll see in movies like Top Gun. They're in radio contact with the incoming pilots and give them directions.
During the approach, the plane reduces its speed considerably to around 250 kilometers per hour. It's managed by the Rafale's central computer. It optimizes speed by slightly pitching up the aircraft and adjusting the canards at the front of the aircraft to maximize stability. The aircraft thus enters the groove, the final 20 seconds before touchdown. The plane is now just a few meters from the Charles de Gaulle. Unlike the runway at L'An de Visio, where the pilots train, there are 3 strands across the deck. 3 cables to maximize the chances of catching one and stopping the plane. The first if the Rafale is a little short, the third if it arrives too far on the deck. The middle one is ideal.
Yes, it's violent, and yet it's sufficiently well designed to be bearable, as we're not Superman.
For the rear landing gear 2, the impact is violent. Therefore, the wheels are oversized compared to an Air Force Rafale.
The tyres are inflated to around 25 bar.
That's a little bit more than car tyres, which are inflated to just over 2 bar. And that's what's needed to withstand the impact. Accidents during deck landings are extremely rare worldwide, and even more so with the Rafale and an aircraft carrier as sophisticated as the Charles de Gaulle. To help with the process, engineers at Naval Group, the French Navy's prime shipbuilder, have come up with a world first. An extraordinary invention called Satrap, a system weighing several hundred tons that counterbalances the sea swell.
These masses of concrete glide to and fro on rails under the deck to balance the carrier according to the state of the sea.
Below decks, it's like a freight train which moves to compensate for the list.
Yet even Satrap may not be enough. If there's a serious problem, a breakdown or a poor assessment of the aircraft's approach, the pilot may eject as a last resort. And here again, the aircraft in its navalized version is modified. On a conventional 2-seater Rafale, the pilot's seat ejects to the right, while the navigator's seat ejects to the left, with a slight delay. This ensures that the two don't collide, while avoiding the tailplane that could cut them in half. On the naval Rafale, which only exists in a single-seater version, the pilot has to avoid 2 obstacles: the vertical stabilizer in the rear and the 10-story island ahead on the carrier.
The island, which is actually the control tower, is on the right of the carrier. So to prevent an ejecting pilot from hitting the island, we took a rear ejection seat from a 2-seater to make sure the pilot is catapulted to the left.
The ejection seat on the Rafale with its 3,000 components is a gem of technology that every pilot dreads using. Even more so on a ship like the Charles de Gaulle, where a plane crash could mean disaster.
It would obviously endanger the ship and the other planes on the deck, while below there are ammunition and fuel stocks, a hospital, mess rooms, as well as 1,600 crew, and of course 2 nuclear reactors. So accidents simply cannot happen.
But such a situation is highly unlikely. The Rafale is one of the safest fighter jets in the world. It's also one of the easiest to maintain. And that's essential in a maritime environment that's extremely aggressive to aircraft.
Even when they're not flying and parked down in the hangar, the ship is at sea. So there's salt everywhere, and that's corrosive. It attacks so quickly you can almost see it. In the end, rust wins.
Yet sea spray isn't the plane's only enemy. The fuselage, turbines, and electronic systems are also subjected to abrasive intrusions. This is where the naval Rafale has another trump card compared with other aircraft, including the most recent. Everything is designed to be interchangeable with a minimum of manpower. The engine, the most sensitive part, has been designed for speedy extraction.
The engine's cowl covers are held by quite a few screws, but they're easy to remove.
Thanks to less time-consuming maintenance, the naval Rafale is the fighter aircraft par excellence on a carrier, in surroundings where every square meter is optimized. An advantage that puts the French Navy among the top players in naval warfare. And it doesn't stop there. The F-4, the latest version of the fighter, has just arrived. It will be followed by the F-5, currently under development, with even more impressive improvements. They are scheduled to fly for at least another 30 years. Their replacement, the SCAF, the Future Combat Air System, is due around 2045 to be operated from the successor to the Charles de Gaulle, which is scheduled to leave the shipyards in 2038. In the meantime, in a tense geopolitical context, France must preserve its territorial waters from unauthorized incursions. And to do so, the naval Rafale is not alone. There are aircraft specialized in patrolling the seas, and their potential, as well as their mission, is exceptional. Among them, there is an aircraft that all enemy forces fear. Its brief is most complex. It's a submarine hunter. It's the Atlantique 2, called ATL-2 for short. It's an extraordinary design, as big and wide as an airliner. Yet it can fly as low as 30 meters above the waves to track down enemy submarines. Under the cockpit, a plexiglass bulb to observe the sea from as close as possible, with a seasoned observer inside.
The first reflex is to raise your knees as if the sea is rising towards you.
In the huge hold, an imposing arsenal with the most potent undersea weapon: torpedoes. Yet, they're set not to destroy a submarine completely, just enough to disable it.
The torpedoes were not designed to cut a submarine in half, but to reduce its operating capabilities and thus force it to abandon its mission.
The new ATL-2 is part of a larger team, made up of frigates, other aircraft, and even submarines. It can locate a target and guide the fire of an Allied ship or plane from several kilometers away.
Imagine yourself noticing a radar pinpointing you from the left, and the missile comes from the right.
Zooming in on an enemy ship from the rear is considered the perfect angle of attack. Yet, If there's a riposte that impacts the aircraft, then the ATL-2 has the ability to survive a crash at sea. The ATL-2 is one of the French Navy's most powerful weapons. It succeeded the Atlantique 1, which entered service in 1965. Its prime mission was to ensure that no hostile ship was present within several kilometers when a strategic nuclear submarine carrying ballistic missiles left harbor. To prevent the sub from being shadowed, the Atlantique 1 could patrol the sea for several hours. Yet, with the Cold War and military technology continuously advancing, the French government decided to invest in a new version. The ATL-2 took off for its maiden flight in 1981. Today, it's in its 6th version. The ATL-2 is all about hunting submarines from the air.
First, you have to detect the sub, track it, pinpoint its position, find a firing solution, and then you come in to drop the torpedo.
Patrolling over the sea means flying for many hours, at high and at low altitude. The first challenge was to design a plane that could adapt to both conditions. The ATL-2 may look impressive, but it's actually quite light. It weighs around 40 tons at most. That's 20 tons less than a medium airliner. And it's provided with a special propulsion system in line with its dimensions.
The plane is equipped with 2 turboprop engines, as opposed to airliners, which are turbojets.
This mode of propulsion allows for very flexible handling, especially at low speeds a few meters above the sea, and a turning circle much tighter than with jet engines.
If you want to hunt submarines, you need to be as maneuverable as a sub underwater.
One of the ATL-2's main assets is its range of up to 4,500 kilometers. However, hunting submarines this far out at sea can be dangerous. If there's an emergency and the plane has to ditch, ensuring the crew's survival requires special features. That's why the ATL-2 is visibly different from other aircraft. It's bi-lobed. Seen from the front, it's shaped like an 8. The single aircraft is in fact 2.
There are 2 separate sections. One is pressurized, the other one isn't. The tactical section provides space for the crew, and the lower one contains the weaponry.
An ingenious configuration that may save lives.
In the event of a crash or ditching, it will float, and thus we'll be able to recover the crew.
It's made up of 12 specialists versed in the detection of ships and submarines, headed by an experienced captain in charge of the mission. Alongside are the co-pilot and the flight engineer, whose job it is to check that the electrical and hydraulic systems are working properly at all times, especially when going down close to the waves.
At low altitude, you could run into birds at any moment, so we'd have to react quickly. And you need 3 people to ensure safety.
Below and ahead of the cockpit, there's the spotter in the bulb. It's one of the aircraft's strong points, as it's highly difficult to detect and identify a suspicious shape at sea. And what even the most sophisticated radars don't pick up, the trained operator's eye can. A protruding periscope will leave a wake in the water, yet no current system can detect it, unlike the spotter. Raising its scope is standard procedure for a sub.
They'll go up, down, up, all the while turning a few degrees so they can get a picture of what's going on around them. Submarines need to observe their enemy visually, but they're not going to leave their periscope up for very long, as they know they'll be detected this way.
It's even possible to see the hull of a submarine if it's just below the surface. Operators have been able to detect submarines like this.
This feature of the ATL-2 is surprisingly complex to build. The manufacture of plexiglass shaped this way is a well-kept secret.
The trick is to achieve a sufficient thickness of the material while maintaining maximum optical quality to be able to shoot pictures through it.
Other detection devices are even more sophisticated, notably the plane's radars. Yet there's a problem. There's no system powerful enough to penetrate deep underwater. Radar waves are absorbed by the water molecules a few meters below the surface. However, on the ATL-2, there is an exceptional device. In the tail of the aircraft is a magnetic detector called MAD. It identifies metallic anomalies in the sea. When there is a high concentration of an opaque metal-like alloy, the MAD sends out an alert. Detecting a vessel in the vastness of the ocean is a challenge, even if it's 100 meters long. But the ATL-2 is a true predator of the seas. And it has additional technological gems to help it in its quest. These are the hydrophones, small cylinders also known as buoys. They're just a few dozen centimeters long. The buoys will do an audio scan of the ocean. Yet, before launching them, the crew needs to know the characteristics of the water, as they are crucial to the correct positioning of the hydrophone.
We drop a small buoy, in fact a sensor. We'll determine precisely at what depth we want it to be, since, depending on the salinity of the water and its temperature, the propagation of sound is not the same in different layers of the ocean. So we adjust the buoy's immersion to where we figure the submarine must be.
Once the data has been analyzed on board the aircraft, the hydrophone can be dropped into the sea. It's then programmed to stabilize at the designated depth and to start listening.
A cable will bring the signal up to the buoy's upper part, which remains on the surface, and a small antenna will then transmit the submarine's echo to the plane.
Hydrophones are dreaded by submarines. They're veritable spies of the seas. They emit no signal of their own, making it impossible for submariners to detect their presence and get away from them. Alas, the hydrophone has a flaw. It can't pinpoint a sub's exact location if it runs silent. To find out exactly where it is, another version of the buoy is sent into the water.
Passive buoys are basically underwater microphones that let you hear what's going on around you. But we also use active buoys, which are little sonars that emit a sound and check if that sound is being reflected by something.
It's actually the same principle used by bats. If the underwater pulse ricochets back to the sonar, the ATL-2 will know the exact spot where the signal has made a U-turn. From this moment on, the ATL-2 no longer prowls on tiptoe. The enemy's sub now knows it has been detected. To engage it, the plane's crew has only a few minutes to launch their weapon.
For its anti-submarine role, the plane is equipped with 4 to 6 torpedoes.
They're the MU-90 Impact, formidable pieces of technology. each weighing just 300 kilograms and 3 meters long. The deadly cargo is carried in the lower part of the ATL-2.
This is what we call the weapons hold. It has two doors that slide into the fuselage.
The aircraft's arsenal is impressive. Apart from the torpedoes, there are Exocet air-to-sea missiles and 250-kilo bombs.
With a maritime patrol aircraft, it's important that no one knows what's inside, what its mission is.
The ATL-2 can release its torpedoes at high speed and at an altitude of several hundred meters. Once submerged, they reach up to 50 knots, almost 100 kilometers per hour for 12 kilometers. They can be set to run 3 meters below the surface or dive to depths of around 1,000 meters. Torpedoes are the ultimate weapons against submarines. Yet, they're not the only ones to wreak havoc. In addition to missiles and bombs, the ATL-2 is equipped with a latest generation optronic ball. Located at the rear of the aircraft, it's a true asset in a combined attack. It can see for dozens of kilometers both day and night, and it operates a laser illuminator.
It designates a target with a coded laser beam, and this can be followed by another aircraft, usually a Mirage 2000 or a Rafale, which will then be able to drop its bombs or fire its missiles on the spot pinpointed by the ATL-2.
However, an attack can take a totally different form when the patrol plane itself launches its weaponry.
It has been demonstrated recently that the ATL-2 can fire its missiles on coordinates supplied by a submarine. This allows us to work as a team and to saturate the target, since it can no longer distinguish between what is illuminating it and what is attacking it. It doesn't know how many adversaries it has to deal with.
The ATL-2 is a flying Swiss Army knife, yet its preferred domain remains the sea. Its successor is expected sometime before 2040. Until then, it will go on flying low over the waves and crossing paths with another iconic Navy aircraft, the Falcon 50. A trijet from French aircraft manufacturer Dassault, an exceptional machine designed to go very high into the sky. It can swallow up distances quickly, but also descend to near wave level to observe ships up close. When the plane is this low, operators can check visually any suspicious vessels approaching French waters. The Falcon 50 has impressive openings for a plane, the portholes. The large windows are also intended to save lives. They allow a close look at yachts or fishermen in critical situations, or small boats in distress. To that end, the plane is equipped with a buoy release system, a risky operation that requires perfect timing.
If released incorrectly, a life could be lost.
The Falcon 50 is one of the French Navy's most used aircraft. To monitor the country's coastlines, the Navy chose a high-performance aircraft which was not originally designed for this type of mission. It was intended for the business world.
The idea was to transport VIPs all over the world without rattling the coffee cup or glass of champagne. Well, we decided to take this civil aircraft and use it to its full potential to carry out the mission.
The Falcon 50 is a formidable tool for crossing oceans in record time. Designed at the end of the 1970s, Dassault's business jet is a 3-engine aircraft, so it can cross the Atlantic Ocean in complete safety. If one engine breaks down, the plane is not in danger. But the configuration also enables the Falcon to dive instantly into the area in question. The Falcon can rapidly descend from 12 kilometers altitude to about 30 meters. This means it can go as close as possible and instantly see what kind of vessel it is. A large carrier, a container ship, or a tall ship. Visual contact is essential to any surveillance mission. It's also a way of imposing authority. A ship's captain is way more inclined to provide information about cargo and course if a Navy plane is circling overhead. A simple radio message from afar has less impact. All boats over 15 meters in length transmit an AIS, the acronym for Automatic Identification System. This information is transmitted over the airwaves to give a ship's position, course and speed. This data is picked up by the aircraft's receiver.
Part of our job is to detect why a vessel doesn't transmit its AIS, to see if it's engaged in illegal traffic or is perhaps a vessel in distress.
Flying close to the water also provides valuable information radar cannot offer. The Falcon's crew, like those of its big brother, the ATL-2, are specialists in ship recognition.
The 2 large portholes allow 2 operators to take up positions when the plane flies at low altitude and makes a pass along the ship. Then they'll take their cameras and shoot a series of photos that will enable us to get a little more information.
The photos are sent directly to servers on land. They are then analyzed and can prompt further intervention. If needed, the Falcon crew can always call up an armed ATL-2 or a pair of Rafales for support. Yet, first and foremost, the 6-person crew rely on their aircraft. Flying so close to a boat and that low over water is a perilous exercise. The pilot usually has only a few seconds to react, especially since to fly at low speed, the Falcon 50 has to pitch up into the airflow. This enables it to fly at 280 kilometers per hour. That's its minimum speed. Any slower, and it will stall and crash in less than 5 seconds.
You always have to take into account the ratio of inclination. Yet with this plane, you can risk really steep inclinations to achieve the mission, as opposed to an airliner or a conventional business jet.
Flying at low altitude requires that the autopilot be dispensed with. It's one of the most important skills pilots are taught, as is visual observation, since there's an additional mission for the Falcon 50. Sea rescue. For this task, the aircraft has one of the best sensors in the world, the optronic ball from the French company Safran. It embeds a computer that merges thousands of pieces of data received every second. However, some elements can escape its sensor.
A radar will detect metal parts in general. A signal detector will detect an electromagnetic emission. Yet the human eye is essential to complete the picture. Put simply, if someone is shipwrecked at sea, radar won't necessarily recognize it, but the human eye can.
It requires maximum concentration in the most difficult flying conditions. At this speed and altitude, you need to have nerves of steel.
With the turbulence due to flying that low, the plane is a lot less stable than an airliner. Sometimes it bounces a lot, so you'd better strap in tight.
Yet when a boat in distress or a person overboard is spotted adrift in the ocean, there's not a second to lose. The aircraft then turns around to position itself for the approach to the target. It's the first stage of the rescue. Then a hatch, measuring less than a square meter, opens in the fuselage of the aircraft. It's a metal curtain that slides open to avoid obstructing the airflow. The operator proceeds to mark the area. He slips a smoke bomb into the hatch, providing a precise marker of the person in distress. The Falcon 50 swings around, and a crew member throws a buoy in the direction of the current.
Once released, the wind will blow it back to the person overboard.
Upon contact with the water, the buoy opens by itself. Falcon 50s are extremely efficient at this type of operation. The aircraft, with its legendary engine reliability, take off day and night, with a crew on standby 24 hours a day. An operational prowess it has in common with the ATL-2 submarine hunter and the naval Rafale. These aircraft are powerful emblems of naval aviation, with a worldwide reputation as an exceptional intervention force. With nearly 200 aircraft, French naval aviation is one of the country's greatest military assets. France is counting on it more than ever to defend its interests and its sovereignty.